Hello everyone, welcome back to another video with Mr. Coder, and in today's video I'm going to show you how to solve St. Chroma, question B from Codeforces Round 1020, uh, Division 3. So you're given a permutation P, which contains of every integer from 0 to n minus 1. So notice a different definition of permutation here. It's not from 1 to n, it's from 0 to n minus 1. All distinct number integers, and they all appear exactly once in each one appears once. So it's a strip of n cells, and St. Chroma will paint the ith cell of the strip in the color of MEX P1, P2, all the way to P of I. So for example, suppose P is equal to 1032. Then St. Chroma will paint the cell strips in the following way. So first it'll be 0 because the MEX of 1 is just 0. Then it'll be 1, 0. The MEX of 1, 0 is just 2. The MEX of 103 is also 2. 1032 is just going to be 4. So the MEX is the minimum excluding, so that just basically means the least positive, or at least non-negative integer, because make sure 0 is also there. The least non-negative integer that doesn't appear in this array. So then you were given two integers n and x, and because St. Chroma loves color x, construct a permutation P of all integers from 0 to n minus 1, such that the number of cells of the strip painted in color x is maximized. So because you want to maximize color x, the obvious solution, you don't want to put color x until the end, since then it can never be the max. But to add on to that, you want the max to be you want if you want color x, you want to get to color x as soon as possible. So you want to do all integers from 0 to x minus 1 first, so that x can start being the max. And then afterward, then you want to do the other numbers, but you want to do all the other numbers greater than x before you do x. So one way you could do that is first go through 0 through x minus 1, and then keep printing out all those numbers. And then you just print out from n minus 1 to x going down and print those numbers. And the reason why that works is because you start by going to the max as soon as possible, and you don't affect the max until the very end. So there are some solutions that don't work, for example, like printing from x plus 1 all the way to n minus 1 and printing x again, because that'll like have a duplicate. So you need to be careful to make sure, since this is a constructive problem, to make sure that you don't like miss duplicate numbers or whatever. So the key thing to notice here is that it's actually a constructive problem, not just a math problem of calculating the number, but rather it's just what is the optimal solution. So as you can see in my code here, I just went from 0 to x minus 1, and then I printed that number, and then I went in reverse. So I went n minus 1 to k inclusive and going down and printed those. So that'll make sure that the number of maxes that is equal to color x is maximized. So this is just a simple constructive problem. And for tips for this problem, I would say, is for these types of constructive problems that are early on, like question B, they typically have some sort of trick up them that's just like some simple thing. So stuff like just printing it up until this number. It's not like you have to do like all this brute force or whatever. You just this is another type of problem where you almost like assume that, and then you prove it true after you assume it. So that's how I got my solution when doing this problem. So yeah, that's basically how you solve this problem. There there are many different ways to do it. It's just the core idea should be the same. You get to x as soon as possible, or x minus 1. You do x minus 1 as soon as possible, and do all the other numbers. So yeah, that's how you solve St. Chroma. Question B from Codeforces Round 1020, Division 3. Thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next one. Bye.